I'm too nervous. Hi everyone, my name is Maggie Prajapati and I'm going to talk about how machines learn today. So before we go into this concept of machines learning, we're going to talk about how humans learn. So how do humans learn? They learn with their environment, by being curious, by exploring, and by interaction. We also learn by experiences, whether they can be good or bad. We also learn from them. Computers, on the other hand, do not learn in the same way we do, and we actually have to train them to learn in the way that we want them to. If we give an example of Plankton, and he wants to know how to get to full stack, we're going to ask SpongeBob, and SpongeBob might give us directions like take the 2 train to Wall Street. On the other hand, if he asks his wife Karen, and in the show she might actually say she knows the answer, but in real life a computer might not know what a place is, a thing is, what you are, or what words are. So in order for a computer to learn, we have to give it a lot of data to understand. My tech talk is going to start off with a brief about artificial intelligence. It's then going to move into machine learning, and then the subset of machine learning called deep learning. So the idea of artificial intelligence emerged in 1956, and it was the idea for engineers to create a machine that had similar qualities to human intelligence. There are 2 classifications to artificial intelligence, I apologize, general artificial intelligence and narrow artificial intelligence. In the sense of general would be something that you'd see in the movies, and then narrow is what we actually use, and it'd be some kind of tool that helps improve human efficiency. Machine learning, on the other hand, is a subset within artificial intelligence, and it's the idea that we're going to give the machine a lot of data, and it's going to train from that data, and when we give it some kind of input, it's going to give us an output. This was the first approach towards artificial intelligence. And so let's look at how that actually works. So if we have a machine and we want the machine to understand this data set, we're going to give it some kind of information. So we'll give it all the qualities, or in this case, just some of the qualities of the data set. We're going to then give it some kind of learning style that the machine will use. And the output that we want to get is if we give some input to the machine, in this case it's going to be an image, we want the output to be something that's correct. So this is the ideal situation for machine learning. The 3 different types of way a machine can learn is using a supervised learning method, unsupervised, and reinforcement. And I'll talk about all of them briefly. So if we look at supervised learning, we're going to look at the machine receiving a data set with all the information it needs. It's going to be labeled, and they're going to get feedback, and it's just going to be very informative. So in this case, if we give the machine this data set, it's going to use some kind of learning algorithm to understand the data, and then it will create a model for itself. In this case, if we give some kind of input, we're going to receive an output from the machine. In this case, if the output is incorrect, which it is, we're going to give it some kind of feedback. So we're letting it know that this is not what we want. In this case, it will continue through the cycle of understanding what the input we're giving it to achieve an output that we want. So if we give it the input one more time, and it actually gives us the correct output, which it does, we're going to say, yes, that's correct. And this is the way it's going to learn. So it will learn until it reaches a point where it actually can associate the correct input with the correct output. The next kind of learning we're going to talk about is unsupervised learning. So unsupervised learning is the opposite of supervised learning. We're not going to give the machine any kind of information. In this case, we just have shapes and colors. So nothing is labeled, so we don't know what it is. In this case, it will use another learning algorithm and then create a cluster model, which it will associate with properties from that data. So in this case, it will separate out the circles and the hexagons. If we then give it some kind of input, we're going to receive an output again, but in this case, even if it's correct or if it's incorrect, we're not going to give it any kind of information. So this is more in the sense of self-learning. The last one we're going to talk about is reinforcement learning. In this case, we're going to give the machine the same data set as we did for this supervised learning, and it's going to do something very similar in using a learning algorithm to provide a model. Once it gets that model, it will then receive another input. And if it gives us an output that's not correct, we're not going to give it any kind of reward, because reinforcement learning has the association of rewards with positive answers. So If we go again and give it the input and it gives us a correct output, we're going to give it some love. Reinforcement learning is more popular and also is something that we do on a day-to-day basis. Reinforcement learning is something that we use as humans and also as animals. Some of the limitations of machine learning include edge cases. So in this photo right here, we're going to see, do we know if this is a dog or a mop? In the case of problem solving, when we look at machine learning, things are isolated. So in case of object recognition, it's going to first find the object and then recognize the object. And lastly, this is the real world and things change all the time. So with the given data sets, things will change, but we want a more holistic view of what we're trying to find out. So here comes deep learning. Deep learning is fairly new. It was introduced in 2006 and then commercially began being used in 2010. It basically focuses on the right features, meaning it will look at more of a holistic view using the input that it gets and then the deep layers that we'll talk about later. So because all of the learning methods come from science backgrounds, we're going to talk about how it uses the artificial neuron. The artificial neuron concept is not very new. It's actually pretty old. It started around 1943. It's modeled after the biological neuron. So if we look at the biological neuron, there are three specific things that we want to talk about. We have the nucleus, which is in the cell body. We have the axon, and then we have the dendrites. The basic concept is that when a signal goes through, it's only going to pass to the next neuron if it hits a certain threshold. This is the idea that the artificial neuron uses. The artificial neuron is a mathematical function which takes some amount of input and then it assigns random weights to those inputs. It will then go through some kind of transfer function and an activation function, which it will then use to decide whether it hits the threshold or not. Similar to the biological neuron, if it does hit the threshold, then the information will get transmitted, and if it doesn't, it won't. The cycle continues until the proper information passes over it. So the idea of deep neural networks is what deep learning is based off of. And in that case, one of the individual inputs is a neuron, but what we have that's more present in deep learning is the deep neural networks. So in them, we have hidden layers, and each hidden layer is going to be a specific feature that it focuses on. Deep learning is more about the holistic view, so each layer will be something associated with how it recognizes the object. If we look at this example of how neural networks used to recognize a dog in a photo, we will see that it goes through that training phase that we just talked about. It will then take an input of a dog's image, and each of the layers, it will start off with just an input layer, which will look at the shapes. It will then go through those different hidden layers. The different hidden layers will focus on different features. So some of them will be focusing on how the dog's face or the legs and things like that will make it a little bit more structured and more confident as recognizing what it is. And it does it in one single process, as opposed to the machine learning techniques where it would first do the recognition first and then the association next. So in this case, the top layer of the neural networks will then decide what the object is, and it will result in some kind of confidence score that will tell us whether it's how much percent it's confident in this answer. So in this case, it's 90% confident that this image is of a dog and 10% confident that this image is of a wolf. So if we look at the benefits of deep learning, we're going to talk about how it handles large amount of data. Machine learning does take large data, but it takes a lot of processing time. In this case, deep learning is faster in processing larger amount of information because it has the computational power that was not present in the past. Now that we have chipsets that are available to us, we can actually make that power to use. And in the same way, it's faster to process information through deep learning as opposed to machine learning. And also because it goes through those high-level features, we don't want a system in place that takes individual pieces and not potentially get the right answer. We want something that can look at everything and get something that's more accurate. So the future of artificial intelligence is kind of already implemented in the daily tasks that we do. It helps us in many different ways. Autocorrect is one of them. Siri is also a great virtual assistant. But deep learning is being used in all of these different methods, and it's also being used for training more and more computers. We can use deep learning in the sense that there are very many companies out there that have APIs available to us, and those APIs can provide us with a score of using the input that we give it. And these are some of the resources that I used for my project, but these are very limited. There are tons of material out there, so you can go in and look at all the stuff about deep learning, machine learning, and artificial intelligence. And thank you. This is my project.